Let's begin. Good morning, good afternoon, good evening. I'm Ann Doyle with Internet 2. Welcome to the second event brought to you by the America's Research and Education Network Partnership. We would like to begin by acknowledging that it's Veterans and Remembrance Day, and we would like to extend our gratitude to veterans joining us today. Thank you for your service. During a recent Internet 2 event highlighting industry involvement with our community, Mary Olson of Oracle showcased the work of an autonomous aerial vehicle pilot, firefighter, and fascinating researcher, Jennifer Fowler. I decided to discuss Jennifer's work with my America's Project teammates, and they are Catherine Antonison and Alex Bushel from Canary, and Tanya Altamirano and Maria Jose Lopez from Red Clara. We all agreed others would be interested to learn of Jen's field work, her data challenges, and ways in which our networks and communities enable research. Our agenda today includes a presentation by Jennifer, and then a video highlighting the work of her collaborator, Angela Maldonado, from a Colombian NGO called Entropica. Importantly, Jen's presentation and the video highlighting Angela's work provide a real-world example of contrasts and impacts of researchers who are connected to our NRENs and those researchers who are not, and why we aspire to connect them. We then have an opportunity for a discussion with the CEOs of our three partner organizations, who are all with us today: Luis Eliezer Carenas of Red Clara, Jim Gadban of Canary, and Howard Pfeffer of Internet 2. We also have a language interpreter team joining us today. In addition to our English speakers, you can elect to hear our presentations in Spanish, French, or Portuguese. You'll notice in the lower right-hand corner of the Zoom window, there is an interpretation feature, and you can select your language there. Hopefully you've already discovered that. We thank our interpreters for their immense talent and support. Let me begin by introducing our keynote speaker. Jennifer Fowler is the recent director of University of Montana's Autonomous Aerial Systems Office, and prior to that served as flight director of the university's ballooning program. She also served as assistant director of the Montana Space Grant Consortium, a NASA higher education program. She is currently a range safety officer and UAS pilot with NASA Langley Research Center. She studied physics at Rutgers University and is completing her graduate work at University of Montana. Please welcome Jennifer Fowler.
Thank you, Anne, and hello, everyone, and I really appreciate you inviting me today. I'm looking forward to share some of my research, and I will share my screen now. And go. And I'm going to talk about work that I have been doing actually for the past 20 years. And I'm continuing actually to do some of that work at NASA, but that is new work that I'm doing. And so I'm really going to talk about where I've come from and where we are now with some of our data collection particularly. And I wanted to highlight this first screen. We think about weather as pretty much a throwing darts at a dartboard to figure out what our weather's going to be day to day. And we've been talking about ways with our team in Montana, how can we make improvements in both our weather and climate models. And first I want to mention, Anne gave thank you for the introduction of my background. And I often have people, they'll say, well, who are you? What are the things that you do? And really to encapsulate that, I say I like to fly things, ultimately. I feel like a kid in a candy store most of the time when I'm around anything that can go into the air. So balloons have been the primary vehicle that I do my research with. And then in the past 10 years, I've moved on to unattended aircraft vehicles or remotely piloted vehicles. And I am also a private pilot, so I do enjoy being in the air myself and feeling some of the bumps that come along with the atmosphere. And when I was preparing for this talk, I came across this slide from 2012. And this slide was prepared for primary school students in Leticia, Colombia. And it was working with Entropica that you're going to hear more about at the end in a video. And what struck me is that I wouldn't change anything on this slide today. This is still everything that we do with our research and our data collection. And I would show you at the top here, it's working with students. It has always been a primary feature of our work. And this is an example of some of the weather balloons that we fly with sensors. This lower left photo and even the center photo are both tethered balloons where we put lots of sensors on them, including cameras, because we've looked at fires from a distance, and I can tell you that latex balloons and fires don't mix too well. And then we also fly larger balloons. So this is a much bigger balloon where we can put payloads that are up to 12 pounds, and it includes cameras and different types of sensors that we fly. And anytime you fly any aircraft, when you see clouds like this, you tend to pause a moment. And this picture on the left is actually from Villarrica, Chile. And this was taken from the surface. So actually when we are on the ground and looking up, I think they're beautiful. But when we're in an aircraft, as on the right side of the screen, and this image is flying into Santiago, Chile in December of last year. This is the moment that you realize you're probably going to hit some bumps in the atmosphere. And it turns out, as uncomfortable as they can be when we're flying, these are very important features in the atmosphere. And these are a manifestation of what we call atmospheric gravity waves. And what we can do is we actually can visualize these waves in the clouds. Although these waves are actually pretty much all over the place all the time around us. It's just not often that we can actually see them. And in particular, what's interesting about these clouds is they are a primary driver of momentum and energy in the atmosphere. And so they're terribly important to capture these in our weather and climate models. And in order to improve those models, we need to actually measure these waves. And that's something that most recently we've been really focusing on in Montana. And I want to mention, when I talk about the atmosphere, and particularly when I talk about gravity waves, these waves, think of them as just a typical wave. They propagate from the surface of the earth down here all the way through the atmosphere, up through the thermosphere, and think of it as a wave breaking at the top of our atmosphere. And one of the things when we talk about balloons, as I mentioned, that's been my primary platform for research. And why we use balloons so much is that you can see here in the stratosphere, balloons can make it this high and actually do research, where we don't have a lot of aircraft that can actually sit in the stratosphere and take the measurements that are necessary. And we also have some instruments that can make measurements into mesosphere and thermosphere, but the type of instruments that we fly with the balloons are the only instruments that make direct measurements. Satellites make indirect measurements, radars indirect, but these balloons, and I'll explain a little bit more in detail of how we make our measurements, really do image the atmosphere, or not image, but sense the atmosphere directly. And in particular, I want to point out these altitudes at 32 kilometers. When we get to this line, we are above 99% of the density of the atmosphere. And when we talk about weather, typically our weather's down here in the troposphere, and then our climate, we look at higher and longer terms of stratosphere. And our balloons take into account data for both of these types of phenomena. And in a little more detail, what exactly are these waves? Picture an ocean or a lake, and it's very calm. And then you perturb that water somehow. Let's say in a lake, you throw in a rock. You see the waves start to propagate. And that's exactly what happens in the atmosphere. And here in this image, what you're seeing are mountains creating that perturbation that starts these waves generating. And what we're looking for is they're pushing momentum and energy vertically through the atmosphere. And it turns out that mountains aren't the only other source of these waves. Other common sources tend to be convection, like thunderstorms or wind shear. And just to mention too, these waves have been known theoretically since the early to mid 60s. But they weren't actually introduced into climate models until the 80s. And it was during that time that it was noticeable that the climate models improved significantly. So chasing these down a little bit more and trying to measure the waves and really capture them well in a model became a top research endeavor, and it continues. Many people are looking into this. And what makes the waves so interesting is literally we can get them all the time because we have mountains, we have storms. But what we don't have as regularly, but also produces them, is things like fires and volcanoes. Both of these can be difficult to actually forecast, to know particularly when and where they're going to happen. So can we make some measurements? And that's why eclipses actually have been the focus of our team in Montana, because we know quite well when an eclipse is going to happen and where the eclipse is going to happen. And in 2017, across the United States, going from west to east, there was a total solar eclipse. And during that time, there were many groups looking for atmospheric gravity waves, actually, because source eclipsed waves were first postulated in the 1970s, and yet through 2017, they had not been definitively detected in the atmosphere. And there was a group from MIT that actually detected waves from the eclipse in the mesosphere and thermosphere using a different technique. And our group had focused really on tropospheric measurements, and the few stratospheric measurements we received, we were not able to definitively say these are eclipse-driven waves. So that actually led us to say, well, we know there's a lot of eclipses. There's at least annually we have eclipses somewhere in the world. So that led us to Chile in 2019. And we went down to Chile with a small team, and we launched near Andacollo, Chile. And our group launched balloons every hour for 24 hours. And with a small team, that means we had very little sleep, but we had a lot of energy, young team, all students. And what happened is we actually found stratospheric gravity waves. So the first detection of these waves from an eclipse. And that is a publication that came out shortly after. And what we also realized is one eclipse is not enough to really definitively say we have our methods down. So we went back to Chile in 2020, December of 2020, and that's the eclipse that you're seeing right here. And the really cool thing about going back down to Chile is it's going to be 28 years before you get two eclipses back to back that travel in the same direction. So in our case, west to east, and over a similar topographic region. And so the Andes Mountains are down there. Those, of course, actually create gravity waves. And we want to distinguish between the mountain waves from the Andes and the eclipse-driven waves. And our 2020 research is ongoing. We're actually working with researchers at Goddard, NASA Goddard Research Center, who is an Internet 2 partner. And something that we, I think, take for granted in Montana is that we can quickly share data with Goddard, and everything just happens to work very smoothly. And we don't appreciate all what's going on behind the scenes. We just know we're getting our data transfers down really well. And I want to mention in a little more detail exactly how we make our measurements. So when I say we're launching every hour, we are literally taking, if you can see my mouse here, let me go back. There's a sensor down here, and I have it on sensors. That's what we call a radiosonde. And it's just a traditional name for these type of sensors that detect temperature, pressure, relative humidity, wind speed, wind direction, and GPS coordinates. And what we're particularly interested in with gravity waves are the wind and the temperature measurements. And then often people will see this little, we call it a derailleur. We need a lot of line between our sensors and the balloon so that the balloon itself doesn't influence our measurement. And this is literally 88 feet of line. I'm sorry, I'm going to switch between units here. And then we attach a parachute because once we get to the stratosphere, the balloon bursts and comes back down. This starts to free fall, and so it's the parachute itself that's making sure we don't just have a fully free-falling instrument coming to the ground. And that instrument's sending data in real time to our ground station that's hooked to a laptop. So we're getting our data in real time. And I'll talk about some of the challenges when we getting that data out, which is right here. Right away, when we do these launches, we get the data. We'd like to be able to share that data as fast as possible. And that is where we tend to have some challenges that I'll talk about in a moment. But this graphic, as you can see, the balloon goes up and literally just follows the wave. That's how we're detecting these waves. Balloons are wonderful, just flying through the atmosphere under the influence of the atmosphere. And so once it hits a wave, it literally just follows a wave, and we can trace that out. And one of the things that we realized is getting, why you could say, well, why do you need to get your data back so quickly? What could you possibly do with it? And what we found is if we can get our data into our model, we can make huge improvements in our models. This is the red line here. This is a graphic where altitude is on the y-axis and we have time on the x-axis. And this is actually temperature values in Villarrica, Chile in December of last year. And the red line is our data that was collected. And then the blue line is the actual weather model that we run. It's the weather research and forecasting model it comes out of the National Center for Atmospheric Research in the US. And you can see there's a fairly large discrepancy between the model and the actual data that we collected. And this black line is what's really interesting is once we get our data, we can put the data directly into the model and remodel and see what the model comes out with. And it starts to match our actual data. So the importance, I can't stress enough the importance of having data as quickly as possible that we can ingest into our models. And once we realized that we could do this, we started to think, where else could this be useful? Because we realized we probably have an area that is, especially in Western Montana, that this could be helpful. And it turns out fire is a big area that we could really increase our forecasting capabilities if we had data that we could put into the models as fast as possible. And this picture I picked particularly because this fire is 10 miles away from where this plane is sitting. And this is 2017, and out of Missoula, Montana is where the plane is. This is a slurry bomber that drops retardant on fires to impede the growth of the fire. This community is on the edge of Missoula. That is a fairly large population center. And there are a lot of lessons that were learned from this fire and the activities that went on. And one of the challenges that we realized came up is some of our spatial and temporal resolution when we are actually doing our forecasts. And that it requires computational resources. And then there's a lack of data to actually validate and improve the models. So data that we can even put into the models. And then there's a mobility issue with our measurements. And I'm going to go through each of these fairly quickly and point out how we've tried to address some of these challenges. And the first thing is the forecasts themselves. I have drawn an arrow here. This is where Lolo, Montana is. Up in here is Missoula, and this valley is called the Bitterroot Valley. And to give you an idea of scale, from Missoula clear down to a pass that's down here, Chief Joseph Pass, it's about 153 kilometers or 93 miles in distance. And I point that out because the fire that you saw the picture in Lolo is kind of a dot really on this map. And yet these big arrows represent our current global forecast. And our global forecast system, this is produced every 3 hours. It is 26 kilometer resolution. And this is not terribly useful when we're talking pinpoint localities and fires. So we have been working on ways to come up with a forecast with higher resolution. And the question that we posed is, what if we could scale down to where we had 100 meter resolution wind forecasts just to start? And what does that look like when you have an influence of terrain features, which in Montana, there's a lot of terrain. So it turns out we actually can do this. And these are 3 or 4 images of the same area. To give you an idea, this is latitude and longitude on the axes, and then we have wind speeds are represented by these arrows and the colors in the arrows. And just to let you know too, this is in miles per hour. So there's some significant wind happening in each of these panels. And if you look at these, you'll see shifts in the wind. And typically along these canyons, you start to see changes in the wind field. And a couple things I want to point out about this. This model was run first on our computers at the university, directly at the university, and it took about 54 hours to actually run this model. And then what we did is we ran it again through a connection with Oracle. That is also a partner with Internet2. And Oracle Cloud Resources allowed us to speed up our runs to 24 hours, which was 53% increase in computational time. And the other thing I'll point out here is that each one of these panels is hourly versus the 3 hours that we get from our global forecast. And we have the ability to make these every half hour if that was of interest. And I also want to mention here that these arrows, it was too much to put in the picture because it gets a little confusing, but these are representative wind fields over an actual fire that happened in 2016. So this was our test that could we test some of this data on fires, and does our model capture the fires well? And the challenge now is, at this point, can we check our model? Were the wind fields representative of what was actually happening that day on that fire? And it turns out that that's a little bit of a challenge as well. This is the Global Radiosonde Network. And so again, this is the Upper Air Network. It represents 30% of the data that goes into weather models. It's a $1 billion industry, and in the United States alone, we have 92 stations, which I would claim is still not enough. And yet the United States has some of the highest spatial resolution of data collection. And they launch twice a day, every day, 365 days a year. And yet in some other countries, and particularly in the Amazon region, many of these dots actually only provide data maybe for 3 months, or on a good year, maybe 6 months. And that's one of the tie-ins with Entropika, is we went down to actually in 2011 and 2012 to really talk about ways that we could improve some data collection. And it gets even worse when I say worse, like this data collection problem becomes magnified when we talk climate. And in climate, when we're making measurements, we're really looking for small changes. And this graphic, the left side is actually, think of this as altitudes, different altitude layers. And the x-axis is temperature in Celsius. And what you're seeing is a variety of different radiosonde launches. And then this microwave sounding unit that's in the squares, which you could think of that kind of as a satellite equivalent. But you can see that each of them we're not getting the same data. There's these discrepancies and uncertainty in the data. So even today, and this is through 1999, I would claim there's still this challenge. Consistency with our data collection is a huge challenge, as well as getting the data out in a timely manner. And it turns out that our challenges aren't, that was temperature, but we also have some moisture issues. So this is relative humidity. And you can see we've got values of relative humidity on the Y and time on the X. And I want to point out these blue lines. They really delineate where in this graph, when you're looking at it visually, you go, oh, this looks like there's some variability in this area. And you might reasonably assume this is due to climate change. But it turns out those blue lines actually correlate with changes in instruments. So each of these radiosonde sites, when they have new instruments, they aren't always taking care to document the change in the instrument and account for uncertainties within the instrument. And therefore, in our climate record itself, we start to see these features that we need to pull out, and it just makes the data analysis a little bit more challenging. And then there's the mobility question. And I'm going to start with just plain mobility, like literally what you think of as how do you actually get equipment to a site? And this is down when we were working with Entropika in the Amazon. We use helium for our launches. There are some groups that use hydrogen, but when we're working around students, it's safer to use helium, and that's what we've chosen to do. And this nice mule got our helium to our site that was in the jungle. And then in Chile, we had to go up a mountain in Andacollo with our tanks of helium. And luckily, the biggest takeaway here that I would say is that two things. One is the mobility of just getting equipment to a site, I think, is equivalent to some of our issues with our network. On the other hand, I think the bright spot is we can do it. I mean, we have connectivity in many different places. So can we improve upon that? And I think it's the same way that we worked with groups to even get equipment to places. It all came down to community and working together. We had groups in Chile. We worked with the SOAR network that's on the Red Clara network. They helped us acquire and move this helium to the site where we needed to get to. So none of this research happens in a vacuum at all. This is all completely, we need our partners and the community that we put together as scientists, because we all have a collective interest in making our measurements and our data availability better. Which brings me back to the impacts here with Entropika. We have worked with Entropika back in 2011 and 2012, and really it came about because Entropika was having some of the same issues we were having with how do you collect some of the data, how do you share some of the data, and then once we have the data together, analyzing the data to really talk about mitigation issues. And for us, it was, when you look at our eclipse work or even our fire work, and specifically, we're trying to improve models that will help people day to day, help long-term climate assessment, help firefighters, all the way to firefighters on the ground, to say, how are you going to efficiently and safely attack a fire? And Entropika had some of the same questions. You know, when we're talking about a group that's really committed to long-term conservation of the Colombian Amazon, and they're working with communities on education and research. They really do need to know, get some data down, even from satellite data that we had always tried to hope we could share with them, but had become somewhat of a challenge, where Angela would be able to look at different areas and look at some of the conflicts that are arising. And Angela, I want to point, Angela's here on the right, and I'm next to her. This was 10 years ago, so we're a little bit younger. But it really blossomed into a wonderful collaboration, and Angela herself is the awardee of the prestigious Whitley Gold Award for research, and particularly in her efforts to tackle the illegal trade of night monkeys for malaria research. And she's also the recipient of the National Geographic Buffett Award in Leadership and Conservation in Latin America. The work that she has done has been tremendous. And with that, I really think I need to let her and her group talk about the work they have done, and I am going to play a video.
Fundación Entrópica is a non-profit organization based in Leticia, Colombian Amazon. We have been working for more than 15 years in the conservation of biodiversity, and also we have been working with indigenous people to alleviate poverty in this area.
Colombia is the most biodiverse country on Earth per square kilometer, containing more than 56,000 species of plants and animals. But its unique biodiversity is threatened by human activities. The illegal wildlife trade driven by human consumption, exploitive tourism, the exotic pet trade, and biomedical research diminishes species populations and even leads to extinction. Devastating levels of deforestation and habitat loss continue unchecked due to extractive industries such as oil, gas, and mining, agricultural production, illegal crops, and road expansion. Armed conflict and systemic corruption undermine the rule of law in the environmental sector, making it difficult to implement conservation actions in these remote regions. Weak or absent governance systems in Amazonian indigenous territories means there is very little investment in economic development and opportunities. Local people have limited access to decent work and often resort to participating in illegal crop cultivation and wildlife trafficking out of sheer necessity. This situation was only made worse by the onset of the COVID-19 pandemic in 2020, when this region became a global epicenter for coronavirus infections. Until May 2021, the airport from Leticia was closed, bringing the tourism-based economy to a grinding halt. Many people who once relied on nature and ethno-tourism activities for income turned to logging, wildlife trafficking, and coca cultivation to provide for their families.
En esa época de la pandemia, pues económicamente la comunidad como tal ha sufrido mucho porque la economía lo generaba el turismo.
To stop environmental degradation, Entrópica has developed a long-term participatory strategy based on local empowerment and citizen participation, law enforcement and training of authorities, and community-based research. We work alongside local stakeholders to search for ways to help them independently manage their natural resource base, improve living conditions in law enforcement, and revitalize their traditional practices. Through a series of court battles and international collaboration, Entrópica successfully halted the traffic of night monkeys from Peru to Colombia for use in biomedical research, and our investigations into this illegal trade have led to disciplinary and criminal investigations of environmental authorities at the local and national level. We carried out a genetic study that confirmed the distribution of Nancy Ma's night monkey at the southern bank of the Amazon River in Peru, shedding light on the most exploited species for malaria research, whose population status at the border has been difficult to ascertain because of unregulated trapping and releasing of primates used as test subjects. Our collaboration with national and international authorities successfully resulted in 2 confiscation operations that ended wildlife exploitation from tourism and improved law enforcement at the border area. Entropica also established community-based tourism initiatives in communities previously involved in the night monkey trade, providing additional revenue for 60 people, increasing their income between 15 and 40%.
Nosotros con Manuel siempre hemos tenido la idea de que queríamos tener nuestro propio negocio. Empezamos con 4 habitaciones. Entonces ahí invertimos pues los pequeños ahorritos que pudimos hacer durante el tiempo que estábamos trabajando. Entonces cuando ya teníamos toda la estructura y le dijimos, Manuel me dijo, ¿y ahora qué hacemos? Porque viene la parte más importante de que la gente lo pueda conocer. Entonces, de esa manera, pues, la Fundación Entrópica nos ha aportado eso para la parte de la publicidad y aún nos sigue ayudando en este proceso. Luego hicimos como una alianza con una comunidad peruana que se llama Visa Alegre. Entonces, lo que hacemos es de que no solamente generar el ingreso económico a esa comunidad, sino también trabajar con la comunidad peruana. Sabemos que es una comunidad que ha sufrido mucho con algunas especies de monos que son exportados o fueron vendidos, digámoslo así. Entonces lo que ahorita ellos hacen es conservarlo. Entonces, ¿de qué manera nosotros, como La Ceiba, le apoyamos a ellos? Es llevando a los visitantes, haciendo como una contrapartida, de que ellos puedan conservar para que puedan mostrar a los visitantes y de esa manera puedan recoger el ingreso.
Pues cuando la Fundación Entrópica ha venido, gracias a ellos había un ingreso, aunque no en cantidad, pero había un ingreso para lo que es para comprar lo necesario en la casa, lo que es el azúcar, el arroz, el aceite. Gracias a la Fundación Entrópica, que eso nos han apoyado harto, ¿no? Ha hecho un esfuerzo la Fundación Entrópica por mandar visitantes para que puedan dejar de pronto un dinero para que las familias se sustenten con eso. Por la Fundación Entrópica han venido muchas capacitaciones para nosotros, cómo conservar, lo que es cocina, guianza en la noche, en el día. Nosotros somos capacitados para poder recibir el visitante que viene.
With our complete wildlife populations database, compiled from 10 years of census data, we provided recommendations for the implementation of hunting bans and restrictions in indigenous territories and wildlife management strategies for the Amacayacu National Park, Colombia, improving wildlife conservation in the area while using night monkeys and woolly monkeys as flagship species. Our efforts in fighting the wildlife trade have brought us national and international accolades, such as the prestigious Whitley Gold Award from the UK, also known as the Green Oscar, the Animal Defenders Prize in Colombia, and in 2020, we received the National Geographic Buffett Award for Leadership in Conservation in Latin America. These recognitions have helped us gain international attention for our conservation work, but have also attracted the ire of environmental offenders who have profited from wildlife trafficking, resulting in intimidation tactics, smear campaigns, and even death threats directed at our team. To improve the conservation of the Nancy Ma's night monkeys, we will evaluate the presence of viral agents to help us understand how arboviruses are spread between forest species, a topic that has been poorly studied at the regional level. This will help unlock a key part of the interrelationship that compromises the health of both humans and non-human primate species. We will also continue supporting local environmental education programs for at-risk Indigenous youth. These programs reach the most isolated Indigenous communities along the Amazon River, characterized by a lack of enrichment, high teen suicide rates, and one of the lowest education rates in the country. By reconnecting children to their cultural heritage, these activities also foster connections to nature. We will continue working with the 2 Peruvian communities that were a part of night monkey trade for malaria research through wildlife watching tourism. As tourism resumes throughout the region, we will help them implement COVID-19 biosecurity protocols so that they may safely receive visitors again. Investing in community-led, low-impact tourism ventures has the potential to increase economic stability for these communities in the long term and will benefit the environment by providing incentive for conservation and alternative income to replace the need for natural resource extraction from nearby territories. We hope that through all our conservation endeavors, we can provide sufficient training and support so that local people can build resilient and sustainable communities that benefit the natural environment and ensure natural resources for future generations. Other than working on these productive projects with the communities, we also work to improve their quality of life. One of the main issues is, and always has been, the access to potable water. This is where we crossed paths with Foundation Ancla from Sweden. Since 2010, Ancla has installed low-cost water filtration technologies in select communities of the Amazon. In 2014, they began looking for a local NGO to take care of this project and make it grow. Today, Entropica and Ancla have installed water filtration systems in more than 20 communities and 5 schools of the Colombian and Peruvian Amazon, providing access to clean drinking water to over 6,700 people in this region. Recently, we have extended the project to include indigenous communities of La Guajira and marginal neighborhoods of Medellin that benefit another 7,400 people approximately. The cooperation between Entropica and Ancla continues to thrive, and other projects have been added in recent years, namely the construction of school buildings and a godparents program that pairs local students with Swedish sponsors to help cover the cost of school supplies, both of which aim to improve education in the Amazon region. Another component of Entropica's work is dedicated to improving the well-being of domestic animals in Leticia. In this project, we focus mainly on spaying and neutering dogs and cats, and teaching the general public that animals are sentient beings, and that animal rights laws exist to protect them. We work with the local authorities to raise awareness about the regulations and laws concerning the responsibilities of being a pet owner. Changing society's attitudes towards animals by helping people understand that animals experience pain just like humans also helps our conservation efforts, because people begin to develop empathy towards all animals. However, we start with cats and dogs since people relate more easily to these animals than, for instance, a snake or even a dolphin. To date, we have spayed and neutered over 2,000 dogs and cats in vulnerable neighborhoods and indigenous communities, and reached 1,900 students with our education program on responsible pet ownership. But now let's get back to the collaboration between Ancla and Entropica. In 2019, we decided to apply for funding from the Swedish Mission Council to address 2 issues that deeply affect the long-term outcomes of any of our projects. These issues are poverty in the indigenous communities and weak civil society. Strengthening civil society by means of empowering communities to claim their rights and independently and sustainably manage economic alternatives, their resources, and community-operated services is indispensable to reducing pressure on the local ecosystem.
I want to thank everyone for listening and opening it up to questions.
So Jennifer, one thing I wanted to do, if anybody has questions, put them in the chat window. We have just a few minutes for questions because I want to be sure we have an opportunity to talk with our CEOs who are here today, who have given a lot of thought to this connected researchers and not connected researchers. Before we do that, we didn't know, because of connectivity issues, if Angela Maldonado would be able to join us today. And I believe she is here with us. And Kelly, if you could spotlight Angela and Jennifer, just because these are 2 remarkable collaborators and researchers, and she is here with us. And I just thought it would be nice spontaneously to have a moment to say hello to Angela. We're so glad you're with us today.
Thank you very much. Hello, Anne. Thank you very much to Jennifer for that amazing presentation. I forgot that those very old pictures where we look very young, fantastic. And yes, it was, I love the job that she's doing now, and lovely to be able to be here. Like I am in Bogota right now, that's why I have good connectivity. Otherwise, if I was in the Amazon, I don't think it was going to be possible to be here today. Thank you, Anne.
Angela, thank you so much. It is really a pleasure and honor to have you here with us. And Jennifer, thank you. What an inspiring presentation and a really inspiring challenge of how much we want all of our researchers to be connected so that you can share your work, share your data. And with that, I actually think it would be great if we could move to our discussion with our CEOs. Angela, stay with us if you can. We had thought a lot about what it might mean to have Luis, Jim, and Howard with us today, having an opportunity to hear from Jennifer and Angela. And I think the question that we're all grappling with is, how can we connect organizations like Entropica and other underserved and yet very important research communities? And I know, Luis, you had some thoughts about this the first time we discussed this, and maybe you could begin our discussion here.
Thank you, Anne. I will begin a few words in English because I'm going to take advantage of the Spanish to English translation. So it's a quick announcement to let you switch in the little globe that is under the window to the correct channel. Muchísimas gracias, Anne. La verdad, hoy vimos una presentación bellísima. Creo que las dos, la presentación de la doctora Jen Fowler, a quien agradezco mucho el apoyo con esta actividad, y la presentación y el video de Entropica, muestran el valor que puede tener la cooperación, la colaboración en el fortalecimiento de nuestras capacidades conjuntas y en el fortalecimiento de investigadores y del uso del conocimiento que podemos tener a nuestra disposición para resolver grandes problemas de la humanidad, ¿no? En el caso de lo que vimos de Brasil, del Amazonas, el Amazonas realmente es una zona muy compleja de conectar. Obviamente por lo intrincado de la selva, y hay algunas iniciativas buscando llevar esa conectividad a esos espacios tan difíciles de atender, que están basadas en la posibilidad de llevar enlaces y cables a través del Amazonas, del río Amazonas, y a través de ese río Amazonas poder llegar a los puntos de conexión y tratar de dar algún nivel de conectividad en el ámbito del Amazonas. Pero esta problemática que en el caso del Amazonas está marcada por una dificultad geográfica, en el caso de Latinoamérica, y sé que también en alguna medida en Canadá y en Estados Unidos, está muy vinculada también a temas de la división digital, ¿no? De la división de acceso a los recursos, que lamentablemente, independientemente de nuestro nivel de desarrollo tecnológico, siempre nos afecta. En Latinoamérica es importante esta división. Y nosotros estamos trabajando con varios proyectos que buscan aumentar la capilaridad de conexión en diversas zonas de Latinoamérica, como por ejemplo a través de las redes comunitarias de investigación y educación, que es una forma de poner la colaboración a trabajar en conjunto para resolver un problema que si no lo trabajamos colaborativamente es muy difícil de atender. Entonces, quería destacar esto. Nosotros, y también quería mencionarles un poco una iniciativa que tenemos, pero previamente a eso, en términos de esa cooperación, yo le quiero agradecer a Howard y a Jim por la voluntad y el interés y el deseo que han tenido de trabajar conjuntamente con Red Clara para construir esta alianza a nivel de América que permita que juntemos esfuerzos para conseguir resolver problemas que son realmente vitales para todos. Creo que vamos en muy buenos pasos. Estos eventos que estamos organizando nos permiten mostrarle a nuestras comunidades lo que somos capaces de hacer. Contamos, como nos lo ha dicho muchas veces Jim en muchas reuniones que compartimos, con unas inversiones enormes en infraestructura que tenemos que saber aprovechar para ponerlas a disposición de estas problemáticas. Cuando pensamos en temas como el cambio climático o cómo la ciencia ha evolucionado a ser una ciencia que cada vez más se basa en el uso de los datos, en la recopilación de los datos, en la posibilidad de usar herramientas complementarias como capacidades de cómputo o capacidades de uso de inteligencia artificial, o lo que va a ocurrir en muy corto plazo cuando empieza a desplegarse con mucha más fuerza todo lo que es el IoT o el Internet de las Cosas. Vamos a tener un mundo en el cual la cantidad de datos que tenemos está muy por encima posiblemente de lo que podemos lograr manejar apropiadamente. Y ahí necesitamos la inteligencia colectiva de nuestros investigadores. Y esa inteligencia colectiva se desencadena a partir de la colaboración y del trabajo que podemos hacer conjuntamente. Nosotros, para establecer esas colaboraciones, hemos buscado un concepto que es una de las maneras que estamos tratando de usar para apoyar esta integración, que hemos llamado la ventanilla o la ventana abierta al investigador. Es un lugar donde nosotros esperamos que investigadores como los que hemos visto hoy y como los que esperamos ver mañana, vengan y nos cuenten de sus necesidades, de sus retos en términos de acceso a recursos para poder hacer su investigación, y por encima de la conectividad propiamente dicha, que tiene que ver con la parte técnica, está la conectividad humana. Esa ventanilla nosotros esperamos, en el caso de Red Clara, poder usarla para integrar a estos investigadores latinoamericanos que tienen cosas que aportar, que tienen ideas, que tienen proyectos, que tienen iniciativas que son relevantes con sus pares, con sus equivalentes en Estados Unidos y en Canadá, y que a partir de eso podamos mostrar un ejemplo de lo que las redes de investigación y educación están en condiciones de hacer. Así que, de nuevo, yo les agradezco muchísimo la oportunidad de poder expresar, y disculpen la digresión de hacerlo en español, pero me resulta más fácil y sencillo, aprovechando que hay traductores simultáneos. Así que muchísimas gracias, Howard y Jim, y bueno, a ver sus comentarios al respecto.
So, Howard, I wondered if maybe you could talk about some of our efforts here in the U.S. to reach out and support underserved but important research and education communities.
Sure. Well, first, let me just thank Jennifer and Angela. That was a fantastic presentation. And so thank you for joining us today to do it. And of course, thanks to Luis and Jim for the continued partnership and collaboration and friendship that we have. So I think Luis made a very important point. Infrastructure obviously is something that, as a research education networks, being networks is core. And there are, of course, many challenges on geography and remote locations, but even gaps in infrastructure in urban areas with different populations that need to be addressed. But I think specifically for research and education networks, who have, by the way, a long history, certainly in the US, many of the state and regional networks have a long history of working with underserved communities, tribal lands, tribal communities, and other institutions to help provide some of that infrastructure and connectivity. But a big part, I think a sort of key thing that research education networks do is community engagement and reaching out to communities and like Luis has talked about with his Open Window initiative. So I can give you one of the examples that Internet2 has been recently focused on. We've been working with a collaboration called the Minority Serving Cyber Consortium, or the MSCC. It's really an effort a collaboration between historically Black colleges and universities in the United States, tribal colleges, universities, Hispanic serving institutions, and other minority serving institutions to work together to reduce or really fill that gap between those institutions and the access they have to the global research and education ecosystem. And in fact, recently, we're very happy to announce that Internet 2 received an award from the National Science Foundation to pilot a creation of a center of excellence with the Minority Serving Cyber Consortium. And the goals of that effort are, number one, increase awareness and support of professional and career development for students, faculty, and staff on the MSCC campuses, enhance communication among the leadership of those institutions, researchers, and CI professionals, increase access to CI resources beyond just connectivity, which is surely a necessary but not but sufficient piece to be fully part of the research enterprise, and eventually to establish the MSCC as an independent, self-sustaining organization. So, there is an example of the role of an NRAN as both infrastructure, but also more importantly as engagement and reaching out to these communities and helping participate in access to the cyber infrastructure necessary to be part of the overall research enterprise.
Thanks, Howard. Jim, I know from other conversations we've had how much thought you've given to this and some of the policy questions, and so I turn it over to you to add your thoughts and input.
Thank you, Anne, and thanks to everyone for organizing this event. I mean, these are things that are very, very thought-provoking for all of us. We see right at the face of science, like some of the challenges that are being that our researchers are encountering. And if I start with the thinking around the notion of a definition of underserved and apply that to the scope of what we're working on, which is the Americas, what we discover is the definition of underserved varies by country. Certainly, you can maybe appreciate that someone who we would deem to be well served in one part of the Americas is actually what might qualify to be underserved in another part of the Americas. And the same sort of thing exists, just as depressingly with the idea of poverty, right? So what's the poverty line in one country might be a high standard of living in another country. So the real question is by what mechanism do we at least appreciate the opportunity to address underserved areas? The second would be, by what authority do we assert that that an area is underserved, and by what criteria are we going to sort of start to think about? And what we hope in the within the Americas project is to sort of look at the methods that that, for example, the one that Howard just talked about, and try to determine, like, can we tease out of there how would we first identify an underserved area? How would we validate that there is some agency or authority that would be responsible for addressing that, and help them understand a more systematic approach to addressing this? Because as we look further and further into the future, we have a problem that exists today with underserved areas, and we continue to run the risk that just continues to widen, because just like the differential between what we deem to be poor and what we deem to be rich continues to widen. And I would be looking for some ability to get together within the Americas and really try to think about a more systematic way of actually going after this, and come up with a structure that says we're going to define that as an overarching objective, which we've already done, and we should be sharing this with more people. A goal for the Americas is which would be whoever should be connected will become connected. And with that goal, then starting to identify things like the characteristics of an underserved area, and then what are the different agencies we can bring together to address that. So it's not a short-term answer that I'm giving you. Certainly, we can learn from activities that are happening in Red Clara and Internet 2 and other areas. But I also believe that if we don't start the journey to figure out how to ultimately eradicate this, we will continue to be having this conversation.
Yeah, I could,
Sorry, I think there's other things that you might, actually, I was going to say, on our previous calls, Howard, I think you talked about, more generic things that are happening.
Yeah, I think, well, certainly one thing that's happening, Jim, to your point about the definition of served underserved, we're at this sort of historic moment, I think, in the US where a very large infrastructure funding bill, hopefully, is sitting on the president's desk and will get signed soon. And there's a significant amount of funding in there for broadband, national broadband plan to address some of the connectivity gaps, and both for obviously citizens, but even for for higher ed for certain higher ed institutions and anchor institutions and communities, and also tribal lands. And so you talk about, well, what's the determination of underserved? And the National Telecommunication Information Administration actually has, the effort there was to create some guidelines around, based on speeds and mapping it to census blocks. And there's a map, the broadband needs map, that you can find online that they created. And then I think that's broadly what's being used to talk about for funding for infrastructure and connectivity. But one of the things that we did with the Minority Serving Cyber Consortium is we actually did a survey of those institutions to talk beyond, certainly including connectivity, beyond connectivity, what else was needed for them to better participate and have access to the overall research infrastructure, the research education infrastructure. And as we know, because we all do this as NRANS, we're beyond, we do more than just providing networking. We provide other critical cyber infrastructure services like the Trust and Identity Federation or the EduRoam Wi-Fi roaming service, and of course access to other services. And so I think part of this is to listen to these communities and understand how they view it. I think that's where we started with our efforts, was going out and listening and trying to understand from their perspective what they felt the gaps were, and that hopefully leads to opportunities for broader collaboration.
Well, and Howard, speaking of broader collaboration, what a nice segue to the second question we hoped to ask all of you. Our team thought a lot about the opportunity with all of you here. Can you talk about the relationship between the America's National Research and Education Project, the project that is sponsoring and hosting this event, and the Global Research and Education Network, the GREN efforts? Jim, I think we had thought maybe the Advanced North Atlantic collaboration might be something you could highlight if you wanted to start there.
Yeah, and I think I saw Ed Moynihan on the call, so he can keep me honest on this, because he was involved in this before I became involved in this, and just coincidentally today is my eighth year anniversary as being president of Canary. This project started even before I became president and CEO. And what it was a recognition that we should be thinking more collaboratively about the connectivity in the North Atlantic. We had at the time at least a couple of dozen circuits connecting Canada to Canada, US to Europe, and then through the relationships that Internet 2 have and their network topologies connecting further south into the Americas. That model proved to be a very, very successful model, and that model is being replicated in other parts of the world to try to address very specific challenges. I want to say probably while we were still able to meet face to face, Luis, Howard, and I met to talk about the identifying the Americas project as one where we recognize that trying to solve the entire global problem would be the same as trying to solve global connectivity. And we looked back at the ANA project and decided, is there a way that, pardon the pun here, doesn't boil the oceans that are connecting us on east-west of our continents, and take a more of a north-south perspective and saying, are there things we could be doing? I guess I would say in our backyards, but in my case, in my south yard, because everything is south of Canada. Actually, maybe Alaska sometimes we think is there too. But nevertheless, you know, we believe that this project is really a forging like a lead initiative amongst, you know, three NRENs, but we're you know, obviously welcome to include as many as possible to say, could we do something that could create a model for how to address intercontinental connectivity within the Americas, and then use that as something to sort of feed into the global initiative to try to either replicate or learn from and adapt, so that real challenging issues that are largely international in nature can be addressed in a more structured way, especially in the Americas, where we tend to always be on very similar time zones, very similar values and approaches, and then try to use that, similar to how the ANA was used to sort of develop an exemplar for how to do better connectivity globally. So it's not a replacement of the GRAN. The GRAN is actually the thing that connects everything. It's the Global Research and Education Network. It uses the definite article, the Global Research and Education Network, and we are just working to figure out how to optimize our own part of that within the two continents. I don't know if Howard and I think Howard and Luis also have very, very strong desires to advance this as well. But
Luis, want me to go?
Hey, thank you. No, as you want.
Yeah.
Go ahead. Howard.
So, you know, I think, and again, we can't underestimate the value of the collaboration and the community aspects of this, and that the capabilities necessary to really support research, whether that's in Americas or globally or domestically, or, you know, require more than just the connectivity piece. And they require everything, starting with, I said, listening and understanding, all the way up through awareness, right? So we're in this, you know, we spent this year really focusing on how do we develop and improve awareness of the amazing capabilities and infrastructure that does exist. I think Jennifer talked about some of the data flows and paths that she needs in order to do her amazing work. And so how do we bring awareness to more researchers and more communities about those capabilities? So that's sort of the first step in the journey. But it continues to go, and historically the collaborations we've had on the global level usually start with smaller groups focused on a specific area, and then there are tremendous lessons learned, people actually making progress and getting stuff done, and then they become sort of the exemplar that then makes its way and can be shared. And I think there's certainly tremendous opportunities in this collaboration to do that. about how do we engage with communities, the services themselves, how do we bring together awareness with federal agencies, with industry partners, and so I think it takes all that to do, and sometimes that is best started with a smaller set of people making progress, and then sharing that and learning from others.
Yo quisiera agregar a ese comentario de Howard que la cooperación que hemos ido construyendo entre Internet 2, Canary y Red Clara se basa, por un lado, en nuestra convicción de que haciendo y actuando en el tamaño y en la escala que podemos nosotros coordinar, puede llevar a entender cuál es el nivel de potencial que tiene la red global de investigación y educación. Realmente creo que no hay nada como eso en términos de capacidad para dar soporte a la ciencia a nivel mundial, pero obviamente empezar con acciones concretas entre actores que se tienen confianza entre sí la suficiente para poder iniciar algunos pasos como los que nosotros estamos dando es sumamente importante. Esta reunión que ustedes presencian hoy viene de un trabajo de varios años de reuniones que hemos sostenido primero en México. Bueno, en México fueron las dos que pudimos hacer presenciales. Esperamos que luego de la pandemia podamos hacer alguna presencial en Estados Unidos y otra en Canadá, pero en todo caso viene de una voluntad de cooperación entre nosotros y una voluntad de hacer cosas, y eso creo que nos ha unido en términos de poder avanzar y mostrar, hacer un efecto de demostración que yo creo que puede permear al resto de las redes. Una cosa hermosa, diría yo, que tiene el mundo de las redes de investigación es que es un mundo colaborativo, no competitivo, con lo cual el aprendizaje que tenemos es un aprendizaje que estamos muy dispuestos a entregar a todos los demás sin ningún costo. Es algo que los beneficia y en la medida que los beneficia a ellos, nos beneficia a todos. Así que creo que estamos en un espacio muy apropiado para poder hacer de esto algo que crezca y que eventualmente permee hacia esa red global de investigación y educación.
Luis, I think that is a perfect note for us to end on. How we extend the work we're doing at a smaller scale to the rest of the world. We are nearing the end of our time, and I do have some thank yous I want to be sure to make. First of all, thank you to our researchers, Jennifer Fowler and Angela Maldonado. We thank you for inspiring us all. You are what we are about, and you keep us going, and you keep us honest. I would like to thank the Americas team, my teammates. And Kelly, I'm going to ask you to try to highlight my teammates. So hopefully they're not blending smoothies or doing something while we're wrapping up here. Catherine Antonison from Canary, Alex Bushel from Canary. There's Alex. Tanya Altamirano and Maria Jose Lopez, who we affectionately call Cote. This is my just absolutely delightful bunch of teammates. We have been working hard together to envision what we might do across the Americas. And so I thank all of you because you're great teammates and honestly very, very fun to work with. And of course, I thank our CEOs, Howard, Luis, and Jim, for your vision and support. I think the work, I feel very lucky to be somebody who works for an organization and part of this global interconnected web of organizations that are doing such meaningful work. And last but not least, thank you so much to our interpreter team You really help bring us all together. We would not be able to be together without your immense talent. To hear our languages and present in many others is a real gift. Thank you. And thank you everybody for joining us today. And this concludes our event.
Thank you all.